Welcome. Today we'll explain how to easily provision an environment with high availability for MetaDefender Core and MetaDefender for secure storage when installed on an EKS cluster within AWS. It is important to note that the main goal of this video is to define the best approach to provide high availability to a system with two MetaDefender products installed on it. Meaning, when installing only MetaDefender for secure storage or only installing MetaDefender Core within Kubernetes, it might not be necessary to set it up with two replicas, as Kubernetes technology provides a self-healing feature. However, it's still a good practice to have two replicas with two pods running in different worker nodes. There are a few components that might go into high loads in some situations, so for those components, it's highly recommended to have more than one replica. The components you can see here listed are the following: the web client, API gateway or scanning service for the MDSS services. Regarding the third-party components, the database, RabbitMQ or Redis cache, for those we can use the external services provided by Amazon with high availability enabled. Let's discuss the recommended architecture. There are three main resources: the load balancer, EKS cluster with services, and databases. We'll go through each one explaining how to replicate them to get a highly available system. The load balancer is going to be the access point for the user or client to make requests to the application. We'll be creating one network load balancer for each application, one for MetaDefender Core and one for MDSS. This service in Amazon can handle millions of requests per second and can be deployed in different availability zones. The second part of this diagram is the EKS cluster, where we will create the necessary components to allow both products to run within the same cluster. The services running on the cluster can be replicated having two pods for each of the components. But for this demo, we'll replicate only the ones that can get into a high load situation. We'll show how to change this setting within the value file in the Helm chart. As you can see here, we have the web client service component that will be a type load balancer, which connected together with the MetaDefender Core service. These two load balancer type services are required to access the MDSS and MetaDefender Core UIs. When having a load balancer type service in EKS, you also need to install the Amazon Load Balancer controller. We'll show during this demo how to deploy an ingress controller from Amazon. Regarding the rest of the services, we can see the RabbitMQ service that will be used as the bridge for communication between the rest of the services. We'll use Amazon MQ with the high availability option. Depending on the storage service that we want to have enabled, we'll create a specific pod for them. For example, for this demonstration, we'll create one for Amazon and Azure Blob. This is what you see here in the diagram referencing storage services group. Regarding the database options, we'll need a Postgres database for MetaDefender Core. For MetaDefender for secure storage, we'll need a MongoDB. Both database services will be installed as Amazon services in this demo. To have these products running with high availability in Azure, you will select Azure PostgreSQL and DocumentDB. For the Redis cache options, we will use the Elastic Cache for Redis that allows us to have high availability for this service. Now let's explain how to easily provision all the resources with a provision script called MetaDefender K8s. But before we see the specific details, we need to go to the MetaDefender Core documentation page, where we will list all the prerequisites like Terraform, Amazon CLI, or kubectl. When setting up the credentials, it's important to set those as local environment variables before running the script. The local environment variables can be exported from a service account in Amazon. For activating MetaDefender Core, we need to indicate the license key as a local environment variable as well. The parameters that can be used by this script are indicated in this table. For running MetaDefender Core together with MetaDefender for secure storage in the same cluster, we need to run the provision action that is required together with the location and the combination of both MetaDefender product flags, so for this case, MD Core and MDSS. Some additional parameters that we'll use in this demo are namespace or cluster name. Now before we run the script, let's edit the number of replicas for some of the MDSS services from the Helm values YAML file. For that, we need to go to our editor, and in the MDSS components, in the values YAML file, we need to add the number of replicas that we want for those services. In this case, the services that we want to have more than one replica are the scanning service. We'll set up 2 along with the API gateway and web client. Now let's move to the terminal where I have the command ready to run with the MetaDefender Kubernetes script. Here you can see the name MetaDefender Demo and the namespace MetaDefender. Once we run the command, it's going to ask if we want to run the latest version of MetaDefender Core, as we have indicated a different image version. We'll say yes. The next question is if we want to create the cluster with EC2 or Fargate. Next, do you have your own access point or want to create an ingress to access? For this demo, we're going to indicate an access point that will generate all load balancer instances to access through the services that are of load balancer type. Next, do you want the load balancer to have an attached private or a public IP? For this demo, we'll select public IP so it's easier to reach the UIs of the 2 products. Next question is, do you have your own database or want to create a new database? Note that when using the script, it is possible to indicate that you have your own database. Indicate within the script the host name, the username, and the password of the database. For this demo, we indicate new, and we'll need to select it as external. Now, we provide the user and the password. The database needed for MDSS follows the same approach, creating an external database and indicating the username and password for the database. For the Redis service, we'll run it as an external service running in Amazon. The same goes for RabbitMQ. Now we see the summary of the selections. We indicate yes, and it's going to initialize Terraform. Now the next command is Terraform apply. That is going to list for us all the resources that are going to be created. When we say yes here, it's going to create all of those resources for us. This can take up to 20 minutes for an Amazon AWS deployment. So we'll pause the video now and get back when the provisioning is finished. We are back after around 20 minutes and the provisioning has finished. You can see how the script has downloaded for us the context that they installed in our local environment, and then we were able to start the installation of MetaDefender Core inside the cluster. For this, we are going to use Helm, and the script is checking if the MetaDefender Core license is set up as a local environment variable. Now it will ask for the username and password for the MetaDefender UI. Let's put that in. Continue, and we'll start to install the MetaDefender Core in the EKS cluster. We can see how it was deployed in the MetaDefender namespace. The next steps are for configuring the load balancer controller script. This subscript is going to create a load balancer controller within the cluster that will automatically create a load balancer in the Amazon account. For this, we need to provide our AWS account ID. For the next part, we need to include the image of the controller, which is different per region. For that, we need to go to this page within the Amazon documentation and pick up the image for the region, that is, in our case, EU Central 1. go to EU Central 1, pick up the load balancer controller image, and now it's going to install the controller for us. I'm going to pause the video as it can take up to 2 minutes. And now we're back and we can see that the load balancer controller has been installed. The next step is to install MetaDefender for Secure Storage, which will be installed after confirming. Now we see that MDSS is installed in the MetaDefender namespace. The next steps are to run some kubectl commands to get the pods in the MetaDefender namespace and some information about the load balancer controller. We run kubectl get pods and indicate the namespace. We see that all the services are running. We have a replica for the API gateway and web client that we have indicated in the Helm chart at the beginning. Also, we can see here that the scanning service has been replicated. Now let's get the services to see the URL that is assigned to each of the load balancers. When accessing that URL together with port 8008, you will be able to access the UI of MetaDefender Core. Using this same URL, you can also access port 80 or 443, which serves as the web client for MetaDefender for Secure Storage UI. Let's go to the browser and take a look at it. Now here we can see the onboarding page for MDSS, meaning that we are able to hit the UI, and for MetaDefender Core, we can see that we are able to access MetaDefender Core as it's already been activated. We hope this helps simplify the process to provision MetaDefender Core and MetaDefender for Secure Storage with high availability. Thank you, and see you in the next video.